All right, let's jump right in. We are going to break down something that is fundamentally changing how AI works, the Model Context Protocol, or MCP for short. It's all about how AI connects to the real world, so let's get into what it is, how it actually works, and why it's a huge deal for anyone building with AI. So here's the core problem we've been facing. You've got these incredibly powerful AI models. They feel like magic, right? But really, they're like brilliant minds stuck inside a box. Their knowledge is frozen from the moment they were trained, and they have no way to see live data or, actually do things in the real world. That isolation is their biggest weakness. And that leads us to the million-dollar question that everyone in the industry is scrambling to answer. How do we let these AIs out of the box safely? How do we plug them into live databases, apps, and APIs without just opening the door to chaos? And that is exactly where the Model Context Protocol comes into play. You can think of MCP as a universal language, an open rulebook that lets any AI system talk to any external tool. It's the standard that makes those connections reliable, consistent, and hopefully safe. I love this analogy people have started using for it, calling MCP the USB-C for AI. And honestly, it's perfect. Remember when we had a different charger for every single device? It was a mess. Now we have one standard, USB-C, that just works. That's the whole dream for MCP. One single standard way to connect any AI to any tool. But to really get why this is such a game changer, we have to look at the problem it's solving. Let's rewind a bit and see what the world of AI integration looked like before we had a standard like MCP. The heart of the issue is what engineers call the N by M integration problem. So imagine you have M AI models and N tools you want them to use. Without a standard, you literally have to build a unique custom connector for every single combination. It's a total nightmare to manage and scale. And this slide just shows it perfectly. On the left, you've got the old way, a chaotic, tangled web where your work multiplies. But on the right, with MCP, you just connect each model to the protocol once and each tool to the protocol once. Your problem goes from N times M to N plus M. It's a massive, massive simplification. So how does MCP actually pull this off? Well, it's all built on a really elegant three-part architecture. Let's break down who the key players are. Okay, so there are three main roles here. First, you have the MCP host. This is the main app where the AI lives. Think of an AI-powered code editor. That host manages one or more MCP clients. Now, each client is like a dedicated specialist, and its only job is to talk to one specific MCP server. And that server is the thing that actually provides the tools, like giving access to your files or your GitHub account. Let's make this real for a second. Imagine Visual Studio Code is your host. It's managing a bunch of different clients. You might have one client that's connected to a server on your computer that can read and write files. At the same time, another client could be connected to a totally different server for your GitHub account. The host is the conductor, orchestrating everything so the AI can use both tools seamlessly. Okay, so we've got the players on the field. Now let's look at how they actually talk to each other. Turns out it's a pretty straightforward four-step conversation. The whole dance starts with initialize. That's the handshake, where the client and server basically say hi and agree on what version of the protocol they're using. Next, and this is key, is discover. The client asks the server, hey, what can you do for me? Then comes execute, where the client says, okay, cool, run that tool for me. And finally, you have notify, which lets the server proactively ping the client if something changes, like a new tool just became available. That discovery step is really the secret sauce to MCP's power. It's as simple as it looks here. The client just asks what's on the menu, and the server gives it a list of available tools. This means an AI can learn about and start using brand new tools on the fly, without anyone needing to update the client-side code. It's incredibly dynamic. And look, this isn't just some theory on a whiteboard. MCP has been adopted by the industry at an absolutely breakneck speed. Let's look at the timeline. So Anthropic first introduced MCP in late 2024, but then, just a few months later, boom, its biggest rivals, OpenAI and Google, both jumped on board. That industry-wide agreement is what really turned MCP from just another project into the undisputed standard. And the ecosystem has just exploded since then. Right now, there are over 10,000 active public MCP servers out there. Think about that. That's a massive, ready-made library of tools that any developer can just plug their AI into, for everything from coding help to complex business software. Okay, now we need to talk about the most important part of this entire explainer, especially if you're thinking about building with MCP. Because connecting an AI to the real world is incredibly powerful, but it also opens the door to some really serious security risks you absolutely have to understand. So let's be crystal clear about what can go wrong. First, you have prompt injection. This is where an attacker tricks the AI into doing something malicious by hiding commands in a prompt. It's like hijacking the AI's brain. Then there's path traversal, an attack that could let someone access sensitive files way outside of the folders they're supposed to be in. You also have to worry about unverified third-party tools. Connecting to a random server is like running a random program you found online. It could be doing anything in the background. And finally, credential exposure. This is a big one. It's when a server accidentally leaks secret API keys or passwords, basically handing an attacker the keys to the kingdom. Let's zoom in on path traversal because it's super common and really dangerous. A normal, valid request might ask for a file inside your project folder. Simple enough. But an attacker can use a tricky prompt with these .. sequences to fool the server into climbing up the directory tree and grabbing sensitive system files, like the password file shown right here. And if you think this is some rare, theoretical problem, think again. A recent analysis looked at thousands of public MCP servers and found that a shocking 82% were vulnerable to this exact attack. 82! That just screams how critical it is for developers to be incredibly careful about validating and cleaning up all inputs when they build these servers. So, despite those risks, which, and I want to be clear, can be managed with careful, secure coding, MCP is absolutely laying the foundation for the next wave of AI. Let's just zoom out for a second and think about what that future looks like.
This quote really just nails it, doesn't it? MCP isn't just some techie protocol. It's a cornerstone piece of infrastructure. It's the thing that's going to let AI grow from being a clever chatbot into a truly connected, autonomous player in our digital world.
And that leaves us with the big, final question that we all need to be thinking about. As this web of connections grows, as every AI can talk to every system, the challenge really shifts. It's not about if we can connect them anymore. It's about how we design, build, and govern this incredibly powerful new world to make sure it's safe and secure for everyone.